Hello everyone, welcome to my channel on engineering mathematics. In this video, we are going to see overview of the concept called as normal distribution. We will also see examples based on it. So let us first see what exactly we are going to cover in this video. First we see introduction to normal distribution. Next, we will see formal definition of normal distribution. Then we will see what is standard normal distribution. Then we will see why to use standard normal distribution over normal distribution. And finally, we will see examples based on this concept. So let us proceed for first point, that is introduction to normal distribution. The normal distribution is a type of continuous probability distribution for a real valued random variable. That means if random variable is discrete in nature, it consists of only distinct and finite values, then this distribution is not applicable to it. If random variable is continuous in nature, it takes real values, then only this distribution is applicable to it. Normal distribution is symmetric about the mean, depicting that data near the mean are more frequent in occurrence than data far from the mean. We will understand this point with the help of graph later on. It follows a bell-shaped curve with the highest point at the mean. Let me help you understand these 2 points with this graph. Here, x-axis represents the random variable. It takes real values. Here is its mean, and this curve represents its probability mass function, f of x. You can see that it is a bell-shaped curve and its highest point is at the mean. And this data is symmetric about the mean. It depicts that the data near the mean is more frequent in occurrence and data far from mean is less frequent. I hope guys you understood this. Now we proceed for formal definition of normal distribution. A continuous random variable x is said to follow normal distribution with parameters mu and sigma square if its probability density function is given by f of x is equal to 1 upon under root 2 pi sigma square into e raised to minus x minus mu square whole divided by 2 into sigma square, where mu stands for mean and sigma stands for standard deviation. If any random variable follows this distribution, that random variable is a random variate of normal distribution. Now, let us see some important facts. In case of continuous probability distribution, we know that integral of f of x dx over the limit minus infinity to infinity is equal to 1. Therefore, in the following graph of normal distribution curve, integral of f of x dx from minus infinity to infinity, which indicates area under the curve, this f of x, it is clear that area under this curve is 1 because of this identity. Now let us proceed for the definition of standard normal distribution. Guys, in fact, standard normal distribution is a special case of normal distribution. Here, mean is 0 and standard deviation is 1. You can clearly see in the graph of standard normal distribution, this probability mass function creates a bell-shaped curve and its peak is at mean, where mean is 0 and standard deviation is 1. Clearly, this curve is symmetrical, bell-shaped and also centered at 0, as 0 is the mean. The area under the curve again equals to 1 and represents the total probability. Now let us see the conversion of normal distribution to standard normal distribution. Any normal distribution with random variable x can be converted to standard normal distribution with random variable z Using a z-score formula, z is equal to x minus mu upon sigma, where x indicates the original value of random variable x, mu indicates mean of the normal distribution, and sigma indicates standard deviation of the normal distribution. So using this formula, you can convert any normal distribution with random variable x to standard normal distribution with random variable z. Now let us see the relation between standard normal distributions, curves, area and probability. You can clearly identify that this curve represents the standard normal distribution. The total area under the standard normal distribution curve is equal to 1. It represents 100% probability. We have already seen the reason of this. This curve is symmetric about the mean, which is 0 here. The area to the left of z is equal to 0 is always equal to 0.5. And why so? Because area covered under this curve is 1 and this curve is symmetric at z equal to 0. Therefore, its area to the left of z is equal to 0 is equal to 0.5. Similarly, its area to the right of z equal to 0 is also equal to 0.5. Next, we see the area to the left of specific z score, say z is equal to z1, represents the cumulative probability. That is, probability of obtaining a value less than or equal to that z score. I mean, probability of z less than or is equal to z1. Here, probability of z less than or is equal to z1 can be given by 0.5 plus area from z is equal to 0 to z is equal to z1. Let us understand this statement with the help of graph. This is standard normal distribution curve. We wanted to find out probability of z less than or is equal to z1. Here is z1 on z-axis. Probability of z less than or is equal to z1 means the area covered by this standard normal distribution curve from z is equal to minus infinity to z is equal to z1. From z is equal to minus infinity to z is equal to 0, the area covered is 0.5. And the rest of the area is area from z is equal to 0 to z is equal to z1. That is why probability of z less than or is equal to z1 is 0.5 plus area from z is equal to 0 to z is equal to z1. Similarly, to calculate probabilities for other cases, we calculate the area under z curve as follows. For example, probability of z greater than z1 is given by 0.5 minus probability of z between 0 and z1. Let us understand this with the help of graph. Here is z1 on z-axis. We want probability of z greater than z1. That means area from z is equal to z1 to z is equal to infinity. It is easy to calculate this area by simply subtracting area from z is equal to 0 to z1 from 0.5, because area from z is equal to 0 to z is equal to infinity is 0.5. So 0.5 minus this shaded part is area from z is equal to z1 to infinity. So we write probability of z greater than z1 is equal to 0.5 minus area from z is equal to 0 to z is equal to z1. Similarly, probability of z from a to b can be given by probability of z between 0 to b minus probability of z between 0 to a. Let us understand this with the help of graph. Here is z is equal to a and z is equal to b. We want probability of z between a and b. That means we want this shaded area. This shaded area can be calculated by simply subtracting area from z is equal to 0 to a from z is equal to 0 to b. Look at here. This red color indicates area from z is equal to 0 to b, and this yellow color indicates area from z is equal to 0 to a. So if we subtract this yellow area from this red area, we will get area from z is equal to a to b. So we write probability of z between a and b is equal to area from Z is equal to 0 to B minus area from Z is equal to 0 to A. Now let us understand why to use standard normal distribution over normal distribution. Let us understand this with the help of an example. Suppose your teacher is marking exam of 100 marks with the passing score of 45 and students score these marks. From these marks, it is clear that not many students are passed. Only 3 are passed. One who got 75, another who got 72, and another one who got 56 are passed. Other students are failed. But if teacher decides to standardize all these scores and only fail people more than one standard deviation below the mean, then here you can calculate mean is 39 and standard deviation is 19.4. Therefore, standard scores now will become these, and you will see only 2 students will fail, ones lower than -1 standard deviation. This technique is improving the result. Therefore, we have to use standard normal distribution over normal distribution. Now let me introduce to you the table called as standard normal distribution table. This table is called as standard normal distribution table. This table gives us the area from Z is equal to 0 to Z is equal to any point. For example, area from Z is equal to 0 to Z is equal to say 1.23 can be calculated as follows. Look for Z is equal to 1.23 in this table. Look, Z is equal to 1.2 in this first column. Here is Z is equal to 1.2. But we want Z is equal to 1.23. So that 0.03 which is missing over here, we will look it for in this first row. So here is 0.03 and their intersection is over here. So this value indicates area from Z is equal to 0 to Z is equal to 1.23. It is 0.3907. I hope you understood how to read this standard normal distribution table. Now we proceed for some examples. In this first example, it is given that in a normal distribution whose mean is 12 and standard deviation is 2, find the probability for interval from x is equal to 9.6 to x is equal to 13.8. Let us proceed for solution. Let x be the corresponding normal variable with mean mu is equal to 12 and standard deviation sigma is equal to 2. We need to find probability of x between 9.6 and 13.8. Now we define the standard normal variate z as x minus mu upon sigma. Therefore, when x is equal to 9.6, z will become 9.6 minus 12 upon 2, which is minus 1.2. So at x is equal to 9.6, z is minus 1.2. Similarly, when x is 13.8, z can be calculated using this formula x minus mu upon sigma. X is 13.8, mu is 12, sigma is 2. So we get z is equal to 0.9. So when x is equal to 13.8, z is 0.9. Therefore, now we can rewrite probability of x from 9.6 to 13.8 as probability of z from minus 1.2 to 0.9. It can be shown in graph as follows. Here is z is equal to minus 1.2 and z is equal to 0.9. So this can be written as probability of z from 0 to minus 1.2 and from 0 to 0.9. Which can be written as area from z is equal to 0 to minus 1.2 plus area from z is equal to 0 to 0.9. But since this curve is symmetric about z is equal to 0, area from z is equal to 0 to minus 1.2 is same as area from z is equal to 0 to 1.2. So instead of calculating area from 0 to minus 1.2, we will calculate area from 0 to 1.2. This term will remain as it is. Now to calculate area from z is equal to 0 to 1.2, we will use standard normal distribution table. Let us check where is 1.2 in this first column. Here it is. After 2, we have 0 in the next decimal place. So we will see the value of 1.20. 1.20 is 0.3849. So we write here 0.3849. Similarly, area from z is equal to 0 to 0.9 can be calculated from standard normal distribution table. Look for 0.9 in this first column. Next decimal place is 0. So we will look into the 0 column. Its value is 0.3159. So we write 0.3159 here. Finally, we add these values to see probability of x between 9.6 to 13.8 is 0.7008. I hope guys you understood this solution. Now we proceed for next example. Here it is given that a student of a class were given an aptitude test. Their marks were found to be normally distributed with mean 60 and standard deviation 5. And we are asked to find the percentage of students scored more than 60 marks. Let us proceed for solution. Let x be the corresponding normal variate with mean 60, mu is 60, and standard deviation sigma 5. Let z is equal to x minus mu upon sigma be the corresponding standard normal variate. Then when x is equal to 60, z can be calculated as 60 minus 60 upon 5. Here I am substituting x is equal to 60, mu is given 60. So we have 60 minus 60 in the numerator, which is 0, 0 upon 5 is 0. So when x is 60, z is 0. Now let us find probability that students scored more than 60 marks. It can be given by probability of x greater than or is equal to 60. But at x is equal to 60, z is 0. So p of x greater than or is equal to 60 represents p of z greater than or is equal to 0. Let us calculate this using graph. Z greater than or is equal to 0 can be shown in this gray portion. And we know that this much area covered by this curve is 0.5. Because this area is from 0 to infinity. Therefore, percentage of students getting more than 60 marks is 50%. We obtain this 50% by simply multiplying this 0.5 probability with 100. So 100 into 0.5 is 50%. I hope you understood this solution. Let us proceed for next one. Here it is given that in a sample of 1000 cases, the mean of a certain test is 14 and standard deviation is 2.5. Assuming the distribution to be normal, we are asked to find how many students score between 12 and 15, and next we are asked to find how many score above 18. Let us proceed for solution. First we define the normal variate x. Let x be the corresponding normal variate with mean 14 and standard deviation 2.5. This data is given. Now we define the standard normal variate z is equal to x minus mu upon sigma. Next we calculate value of z at x is equal to 12 and 15. At x equal to 12, z will be 12 minus 14 upon 2.5. We are using this formula over here, which is equal to minus 0.8. Similarly, at x is equal to 15, z will be 0.4. Therefore, probability that x will take value between 12 and 15 is same as probability that z will take value from minus 0.8 to 0.4. This can be shown in a graph as follows. Here is z is equal to minus 0.8. Here is z is equal to 0.4. We want to calculate this area from minus 0.8 to 0.4. This area is same as area from z is equal to 0 to 0.8 and area from z is equal to 0 to 0.4. Now let us use standard normal distribution table to find this area. First we find area from z is equal to 0 to 0.8. So look for z is equal to 0.8 in first column. Here is 0.8. So 0.80 is 2.2881. So this is 0.2.881 first value. Now we calculate area from z is equal to 0 to 0.4. Look for 0.4 in this table. So its value is 0.1554. Finally, we add these two values to get 0.4435. Therefore, the number of students score between 12 and 15 now can be obtained by simply multiplying 1000 cases, that is 1000, with this probability, which is equal to 443.5. You can round this figure because this figure indicates the number of students. So it is approximately 444 students who score between 12 and 15. Next we calculate how many students score above 18. For that, we will calculate z value at x is equal to 18 using this formula. We see z is 1.6 when x is 18. So probability that x is greater than or is equal to 18 is same as probability that z is greater than or is equal to 1.6. Let us understand this with the graph. Here is z is equal to 1.6. Z greater than 1.6, that means this gray part we want to calculate. And this gray part can be easily calculated by subtracting area from z is equal to 0 to 1.6 from 0.5. So let us calculate area from z is equal to 0 to 1.6 using standard normal distribution table. Look for 1.60 in this first column. Here is 1.6 and this is 0th column. So 1.60 is 0.4452. We subtract 0.4452 from 0.5 to get probability of x greater than or is equal to 18, which is 0.0548. Now we multiply this probability with these 1000 cases to obtain the number of students who score above 18. We find it is equal to 54.8, which is approximately equal to 55. So 55 students score above 18 marks. I hope guys you understood this example. Now let us proceed for interesting example. Here we are given that for a normal distribution whose mean is 2 and standard deviation is 3, we are asked to find the value of the variate such that the probability of the variate from the mean to value is 0.4115. Let us understand this question. Given that there is a normal distribution whose mean is 2 and standard deviation is 3. So we assume that normal distribution variate is x. Its mean is 2 and standard deviation sigma is 3. We have to find the value of that variate. Say that value is x1 such that its probability from mean is 2. So its probability from 2 to that value, say x1, is 0.4115. I hope you understood this question. So here we have to find out that particular x1 whose value from mean is 0.4115. So we have to find the value of that variate, say x1, whose probability from 2 is 0.4115. Let us proceed for the solution. As I said, let x be the corresponding normal variate and let x is equal to x1 be the required value of that variate whose probability from mean is 0.4115. Exactly what I said. The probability of x from mean to that x1 is 0.4115. Given that normal distribution's mean is 2 and sigma is 3. Let z be the corresponding standard normal variate with formula x minus mu upon sigma. when x is equal to 2, z will become clearly 0. And when x is equal to x1, z will become x1 minus 2 upon 3. Therefore, probability of x between 2 and x1 can be written as probability of z between 0 and x1 minus 2 upon 3. But given that probability of x between 2 and x1 is 0.4115, so this is equal to probability of z between 0 and x1 minus 2 upon 3. This can be written in terms of area. So area from z is equal to 0 to this point is equal to 0.4115. So let us search the standard normal distribution table where we find area is 0.4115. I see 0.4115 lies at 1.35. So value of x1 minus 2 upon 3 is 1.35. Finally, we simplify this to calculate value of x1. I see x1 is 6.05. So this is the required value of the normal distribution variate whose probability from mean is 0.4115. I hope guys you understood this solution. Now it is your turn to solve some examples. These are a couple of practice examples for you. Their final solutions are also written over here. Guys, please write me in comment box whether you were able to solve these practice examples or not. Please also write me how much useful you find this video. In my next video, I am going to cover the topic called as exponential probability distribution. Till then, keep practicing these examples, keep watching my videos. Thank you all of you. Thank you for watching this video. Please subscribe my YouTube channel and press the bell icon to get updates about my new videos.